Hello, class. Good evening, everybody. Let me take a quick picture of the attendance today, and then we go ahead to talk about the last section of chapter 10. The coming exam, exam 4, covers the last two chapters, chapter 9 and chapter 10. And we have one more section to go. Good evening, Charlie and Kelly. Okay, so section 10.2 talks about regression. And what is regression? Regression is a statistical method that we use to examine the relationship between two variables. Linear regression is to investigate the linear correlation between two variables. We have two data sets. Is there any linear correlation exists between the two data sets? And regression or linear regression is to use to figure that out. Regression line is also called the line of best fit. It's the line that best fit the linear pattern between two variables. So this is the center of this section, the regression line. This is a regression equation. Line is a geometric concept, right? Point, line, plane, equation is an algebraic concept. So here, regression equation is the equation corresponds to the regression line. Yeah, they are actually the same thing, just named differently from different perspectives. Yeah, this equation is the regression line. We have more concepts here. The regression equation expresses a relationship between x also is called an independent variable, and y hat, actually more specific is y hat. Y hat here is the dependent variable. Y hat here is the estimate value of y. So we call the regression line the line of best fit. That means the regression line fits the linear pattern of the scatter plot the best. Then when we talk about best, we need to have a criteria, right? What is the best? The criteria here is the least square property. Yeah, let me explain that. So let's say we have a scatter plot. We have a bunch of points, right? Yeah, we talk about scatter plot already from the previous section. Yeah, there is a straight line. Best fit the linear pattern here. There's only one straight line. Best fit the linear pattern here. The reason this specific line best fit the linear pattern is because the square of those residues, the sum of the square of the residues is the smallest. Let me explain what is a residue. As you can see from this graph, this point is one of the points in the scatter plot, right? Yeah. So if we look at the distance, vertical distance between the point and the line, and that is that's 11, right? Yeah, that is a residue between that specific point and the regression line. And if we look at this specific point below the line, and we also can find out the residue. Yeah, in this case, because it's below the line, the residue is negative 13. So suppose we have 1, 2, 3, 4. Yeah, seemingly in this scatter plot, we only have 4 points. Then we should have 4 residues, right? Yeah, the first residue, let me move this somewhere else. The first residue is 11. Second residue is 7, it's right here. Third residue is negative 5, yeah, below the line. And the last one is negative 13. The criteria is to look at the sum of the square of the residues. So we are going to take the square of all the residues. 11 square, 7 square, 95 square. 95 square is 25 positive, okay? Yeah, the reason we have to square them is because some residues are positive, some residues are negative. If we do not square them and only add them up, then the negative and the positive could cancel each other. Then that will distort this T-O-R-T, will like twist, it will distort the variation of those points from the straight line. So that's the reason we have to square them. The idea is similar with the formula of the standard deviation, if you remember that formula. And then we are going to add them up. Yeah, if there is a line, the sum of those residues is the minimized, is the smallest, then we say that straight line is the line of best fit or regression line. Let me know, am I clear about that? That's something pretty important in theory that we need to know. Yeah, best fit. What's the criteria for best? The criteria for the best is the least squares property. The name of the property actually explains the standard. Least means the smallest. Squares of what? Residues. Okay, thank you, Kelly. Yeah. Good news for us is you don't have to manually. Yeah, we do not have to manually to find the line of best fit for a given for 2 given data set. We have technology to help us. All right. Yeah, let me show you how do we do that. Let's look at this question. All right, let's look at this question. Use the given data to find the equation of the regression line. Yeah, that's the concept we have just encountered and learned, right? Regression line of best fit. Examine the scatter plot and identify a characteristic of the data that is ignored by the regression. So 3 parts. Yeah, we do 1 part at a time. Since the first part is to construct the scatter plot, right? Yeah. So let's do that. Everybody, do you have your TI-84 calculator ready? And where should we go? We should go to Stat and Edit. Stat. And Edit. If you have some history data, you want to use that line, you can clear them. Yeah, I always use L1, L2. Then later I don't have to change nothing. So I would clear the first two lists. I'm going to enter those values for x in the first list. So I have 9, enter, 7, enter, 11, enter, 10, 11, 13, 5, 4, 13, 6, 6. All right, let me double check. 9, 7, 11, 10, 11, 13, 5, 4, 13, double 6. All right, very good. It never hurts to double check your values. In the second list, I'm going to enter those decimals for variable y. I'm going to be quiet for a little to concentrate. Okay, let me double check my entries. All right, so now what do? We want to construct the scatter plot, right? We are going to go to second y equal. Second y equal. Second is the like a blue purple color key, you know, very easy to find. It's different color from other. Y equal is right above it. The key y equal is the upper left corner key. And then you would see plot 1, right? Yeah, there are more options, but I always use the first one because the first one is always turned on. If I use others, as you can see, the second one is off, third one is off. I have to redo everything. So I would always use the plot 1 because it's already on. And on my calculator, the first one is scatter plot and it's already highlighted. So highlight the scatter plot. The first one in the first row, you would see 6 types. You choose the first one. And X list is R1, Y list is R2, and you choose your preferred mark. I use the biggest one. Yeah. And then what do we do? Yeah, super again. And then we are going to enter graph. Where's graph? Graph is the key at the upper right corner. Yeah, I enter my graph and I don't see nothing, then you have to adjust. Okay, yeah, how do we adjust? We are going to enter zoom. In the list of zoom, you select number 9. Yeah, so we go to zoom and go down the menu to confirm number 9, zoom stat, and then you would see the scatter plot. Yeah, let me know. Do you have the scatter plot in front of you? And which one from the ABCD, which one is the same as yours? C. Awesome. Yeah, I want to make sure everybody is catching up on this part of the question. Yeah, how do you construct a scatter plot? That definitely is going to be on the test. Yeah, it is C, right? Yeah, very obviously C has a this kind of like a outlier thing. Yeah, with this outlier, without this outlier, the pattern of the the pattern of the scatter plot is different. Without this outlier, it's very, you know, the linear pattern is very obvious. But with the point, it's a little bit tricky, even more tricky. Okay, that's the first part, and the first part is not new. The second part is new. Find the equation of the regression line. Okay, how do we do that? It's actually pretty easy. We are going to go to stats and then go to tests. Go to stats and go to tests, and all the way down to select letter F. Letter F is called a linear regression t-test. We actually used that last time, right? Yeah, linear regression. Yeah, the same function to figure out what is R, what is a coefficient, linear coefficient, linear correlation coefficient. Yeah, same thing, same one. And X list is R1, Y list is R2. Yeah, that's the reason I always use the first two if I don't need to keep any data in my calculator. This is why I don't have to fix it. So knowing the test is not equal to 0, choose not equal to 0 is a two-sided test. And then calculate. Okay, so now you should see a bunch of information. Yeah, what information would you see? You would see y equals a plus bx on the top, right? And let's skip t, the test statistic. Let's skip p. The capital P here is the p-value. We don't really need it in this case. Degree of freedom, we don't need it. And what we need is the value of A and value of B. You probably need to scroll down a little bit to see the value of B. My value of A is 3.601, 08, 156, 156. Yeah, my B is 0.45, 97, 69, 50, 35. Yeah, let me know, do you have the same thing with me? I really think the only trouble part for me is to enter those values. All other things pretty straightforward. Awesome, very good. Yes, rounded to A is 3.60. Yeah, let's see the rounding requirement here. Yeah, round the y-intercept. Okay, here I have a question. What is y-intercept? You know, A is here, B is here. Is A the intercept or B is the intercept? This takes a little bit algebra. Yeah, can you answer me? What's the intercept? Yeah, A is the intercept. Awesome. Y-intercept. Perfect, exactly. Thank you, Kelly. Yeah, A, the first one, A is the intercept. B is the slope. Yeah, B is the coefficient of variable x. That is the slope. Perfect. So we need to round A as 2 decimal places. It is 3.60. Very good. And B rounded to 3 decimal places. So it's a 0.460. 0.460 because 9 hold on. Yeah, because 7 is bigger than 5, so round it up. So 6.460. 3 decimal places. Let's see if you have the same thing with me. Exactly, Charlie has the exactly same thing with me. Awesome. I'm happy that you are paying attention for the rounding rule. Yeah. In the past, I had students that messed up the test only because of the rounding. Because every time you have to round it. So that's the second part. And the second part is new, is actually the focus of 10.2. You will see similar problem in the fourth exam we're going to have next week. Identify the last part. Identify a characteristic of the data that is ignored by the regression line. Ignored by the regression line. Let's see if we can. I used to know how to put a line with the scatter plot. Let me see if I remember that. We have. Oh, you would have to do y equal. Let me give it a try quickly. 3.6 plus 0.46x. Okay, and then let's try. Oh yeah, I got it. Guys, if you want to see the regression line that best fit this pattern like that on your calculator, this is what you do. You go to y equal. You go to this key. And you are going to enter, you will see y1 equals, y2 equals, and so on and so on, right? I use y sub 1. Y sub 1 equals, you enter 3.6 plus 0.46x. Yeah, how do you find the x? You do alpha. You do alpha, and another key is STO. STO. Yeah, I need a flashlight to look at exactly what's on the key. Yeah, STO, like a right-handed parentheses. As you can see, the X is on the right shoulder of STO, right? Yeah, so if you do alpha STO, you will see X there. Yeah. So you enter Y sub 1. After that, and then you go to graph, and you will see the best fit. You will see the line of best fit on top of the scatter plot. Do you see that, guys? Pretty neat, right? PID4 calculator can do a lot of things. Awesome. Thank you, Dustin. Yeah, thank you, Kelly. Awesome. Yeah, if not, please feel free to ask. Okay, then what is ignored by the regression line? From what I see is it ignored the point. As I said, it's the outlier. And outlier and the influential point is different, by the way. Two different concepts. But as you can see, ABCD doesn't mention outlier at all, because more important is the influential point. From the name, we can guess what is the influential point. It means if you have that point and without the point, with the point and without the point, the regression line is very different. It makes a huge difference with the point absent and with the point present. So I would choose D. There is an influential point that strongly affects the graph of the regression line. You might remember from, yes?
Question for you. So the question asks, so identify a characteristic of that data that is ignored by the regression line. I mean, of the ones available, it does appear like influential point. And do we need to know the difference between influential point versus outlier? Because I don't. Thank you.
Outlier is the point like far away from other points, like distance-wise. Influential is more related to the regression line. It means without it. So if we remove it, we would have a regression line. If we include it, we'll have another regression line. And the two regression lines are very different. If that happens, then the point is the influential point.
Okay, got it. That makes sense. Thank you.
No problem. Thank you for your question, Kelly. Yeah, if you look at ABCD, A, the data has a pattern that is not a straight line. I would not agree that. B, there is no trend. It does have a trend. C, there is no characteristic that is ignored. I would choose D because this point is so obvious here. Very obvious. All right, any question about this problem? Part 1 is not new. Part 2 and part 3 are. Any questions? I think it's fun that if you enter the regression line equation and you can add the line on top of the scatter plot, it's pretty cool. Okay, if not, let's continue to look at this problem. Find the regression equation, letting the first variable be the predictor or independent variable. Using the listed actress-actor ages in various years. Find the best predicted age of the best actor winner, given that the age of the best actress winner that year is 60 years, is the result within 5 years of the actual best actor winner, whose age was 38 years. Okay, so normally, mainly I just look at this table, you know. Yeah, the table gives us two data sets, two variables. The first variable is the age of the best actress. The second variable is the age of the best actor. Yeah, that's all it matters, right? Yeah. Okay, guys, let's take time to enter those two sets of data in our calculator.
Another question. So for regressions, does the data need to be independent or dependent, or does it not matter? Because this would be independent data, right? It wouldn't be paired.
That's a very good question. I think we do both. Linear regression is to examine the linear correlation existence to see if there's a linear relationship between the two data sets. Paired or not paired doesn't matter. Yeah, that's a very good question. Did I answer your question?
Yep, that answers my question. Thank you.
No problem. Yeah. So yeah, that's my second favorite part. to enter those data. Yeah, please let's do that. Yeah, as I said, I'm going to clear everything. I use L1, L2. Okay, 29. Please do the same. Best actor age, 41. Okay. Yeah, this time I double check after I enter both lists. I can just glance both values for each pair. All right. And then what do we do, guys? Since the question is asking the regression line equation, right, or formula, we are going to go straight to stat tests. And this time, if you go up, it's closer. Yeah, if you go up to click to select letter F, and actually we don't have to change anything here. Yeah, that's the benefit to use L1, L2 always. And I calculate. Yeah, let me tell you what do I have for this question. On the top, we have y equals a plus bx. Yeah, again, you need to know which one is the intercept. A is the intercept, y-intercept. B is the slope. Yeah, then you know how to round it. And then I see the value of A is 52.66657.223. My B is negative. Negative slope means what? It's going down. The line goes down. 1, 9, 8, 7, 2, 9, 10, 51. Yeah, let me know, do you have the same thing? If not, probably when you enter those values, you have some error. Yeah, that's why entering those values is so important for us. Do you have the same thing, guys? Awesome. Thank you, Miranda and Kelly. Oh, Charlene already have that. So first, one decimal place, 52.7 exactly. And slope 3 decimal places, negative 0.199. Awesome, exactly. Exactly. Thank you, Kayla. You have the same thing. So I'm gonna enter. So you're gonna enter the first cell is 52.7 here. Yeah, put the first cell. And the second cell you're gonna enter negative 0.199. Right? Yeah. And next part of this question is very important. Yeah, very, very important. it kind of like tempted. You are going to enter x equals 60 here to find the y hat, right? But you know what? We should not be that careless. Yeah. Why? Because we don't know if the model is a good model or not. So how do we know using the regression line to model the scatter plot is a good idea? How do we know that? What if there isn't a linear correlation between the two data sets at all? You would always have a line of best fit. Even the scatter plot like a no pattern at all, yeah, you will still always find a line of best fit. So it does not mean the line of best fit will give you a good prediction. One usefulness, yeah, one purpose of the regression line is to predict if the regression line fit the linear pattern very well, could really describe the linear trend very well. So this function is based on the fact there is a linear pattern exists and the line of best fit describe that trend, the pattern, linear pattern. But we don't even know this, right? So what do? Let's go to graph. Yeah, I don't have to change nothing because I should have okay, if we go to the graph, I see the line, but I need to change the line here or just clear it. Or yeah, I have, remember in the previous question we have y1 equals a function, y1 equals the regression line, the right hand side of the regression. You want to erase that, and then you go to graph, and then you go to zoom number 9. Do you see the scatter plot? Yeah, my scatter plot in this case look like this. Like yeah, this is my scatter plot. Yeah, even just using visual examination, we know the pattern is not very linear, right? Yeah, but it still gives you a regression line. But it doesn't mean the regression line is a good model. So in this case, when the regression line is not a good model, the scatter plot is a mess. Yeah, exactly. Is a mess means there's no obvious or clear linear pattern, right? Or any other pattern. So in this case, it shows the regression line is not a good model. When the regression line is not a good model, how do we predict? This is the time you need to take notes. We use y bar to predict. Use y bar to predict. And it has nothing to do with the value that is given for x. Okay? Yeah, very, very important for this part. I'm not sure if you would encounter such part in such question, but you need to know this is very important. Yeah, it doesn't mean you have a regression line. You're gonna always use a regression line to predict the future value, whatever within the scope. We would have to make a decision. If this is a good model, we use. If it's not good model, we use y bar to predict. Okay, remember our y values in list 2, right? This is how do we find the y bar. How do we find the y bar? We are going to go to stat, calc. Yeah, let's go to stat and then calc, and then one variable stat. And then this time you need to enter L2 for lists. You need to enter L2 there, okay? Because our Y values are stored in L2. And then calculate. Calculate, you will see X bar. Yeah, you will see X bar, but that actually is our Y bar, okay? Yeah, that actually is our Y bar. But on the calculator, it's gonna be X bar. I got a number equals 44.8, 3 repeating. If we round it to the nearest whole number, it's gonna be 45 years old. Okay? Yeah, this time regression line is not good model. Yeah, let me show you what's the regression line here. How does it fit those like a messy scatter plot? If I enter y equals 52.7 plus, oh, the minus, so 52.7.
So question, if they were asking for predict the age of the best actress, we would use L1 because that would be X bar.
That's a very good question. That's a very good question. The reason you will not have that kind of problem is because the X is the predictor variable. You always predict Y. You always predict Y, unless the question reverse the two data set. Otherwise, always predict for Y value. Does that answer your question?
Yes, that makes sense. Thank you.
Okay, no problem. Yeah. So let me enter the equation of the regression line and draw the line of best fit on the scatter plot. So here we have this X, and then, okay. So the best fit, the line of best fit is like this. It's there's one more point here, actually. One more point here. The line of best fit is kind of like, no, here. Kind of like that, not accurate. Okay, guys, you could enter this equation in y1 and you look at it yourself. Yeah. So very, very important, the second part. All right. Either with or without this type of problem in the test, this is a very important part. And the last question of this problem says, is the result with the 5 years of the actual best actor winner whose age was 38 years? Oh, the actual best actor winner age was 38. And you would say no, right? Because 45 and 38 has a pretty big distance. Yeah. The predicted age, 45, is more than 5 years. Than the actual winner's age. Okay, guys, am I clear about this problem? How do we predict the y value? Earlier, this one actually doesn't have the prediction. You will see one later. Yeah. We only use the regression equation to predict when the regression is a good model. In a case it's not good model, like this question, we do not use this equation at all. We use y bar. We use y bar, the average of y values, as the prediction of the y. Okay, thank you, Kelly. So those three questions are the last three questions of the review that you need to pass, right? Yeah, you have to pass that review in order to take the test. So please work on the review before you go to the testing center. Because this time, if you do not do the review, you will not be able to attend the test. Yeah, let me make it very clear. On the test, test 4, cover chapter 8, cover chapter 9 and 10, you will have 18 questions. The first 6 questions are about hypothesis testing regarding a claim of the population proportion. And number 7, number 8, and number 9 is hypothesis testing of a claim regarding the population mean. Number 10 to number 12 is about, yes? Question? Oh, okay. So from number 10 to number 12 is about hypothesis testing of, do you guys remember what is that? The mean of the differences, right? With two variables, they are dependent. They are dependent. If we have two data sets, they are dependent, or samples. Yeah, this also including a question about the confidence interval. Confidence interval. Not all of them are hypothesis testing. I just put them together. Yeah, 10, 11, 12 are about mu sub d. I think 2 of them are about the hypothesis testing. 1 of them is to find the confidence interval. And number 13 and number 15 is about hypothesis testing, the formal test of rho. Yeah, guys, do you remember what is rho? We learned that 10.1. Rho is the population parameter. The corresponding sample statistic is R. Yeah, R is from a sample. Yeah, R is the correlation coefficient, linear correlation coefficient. So number 13 and number 15 is about to determine there is a linear correlation between the two variables, or there isn't a linear correlation between the two variables, something like that. Number 14 is to construct a scatter plot. Number 16, 17, and 18, the last 3 questions, is 10.2. And the 3 questions there's one more. Sorry, I apologize. So it's about y hat. Yeah. So the last 3 questions is about the section, the last section 10.2. And our review, you know what, has exactly the structure, same structure with the actual test. The review also has 18 questions. The first 6 is about the hypothesis testing of P, 7 to 9, hypothesis testing about the mu, and so on and so on. Okay, yeah. The 3 questions here I have, yeah, we only cover 2. Yeah, we have 1 more. Yeah, it's the last 3 questions on the review. They are pretty close to the 3 questions the last 3 questions in the test, but not exactly. And later, after this question, we're gonna practice another 3 questions. They are even closer to the actual 3 questions on the test. Yeah, let's do this one. Suppose IQ scores were obtained for 20 randomly selected sets of twins. Sets of twins. The 20 pairs. So now I know sample size is 20. Yeah, the 20 pairs of measurements yield X bar. Yeah, so the average. What is it about? IQ scores. Yeah, the average of the. Oh, so basically, my understanding is X is the IQ score of the second baby in the twin. Then Y, find the best prediction given that the twin born second has an IQ. Then Y would be the firstborn, right? Did it say anything like that? Suppose IQ scores were obtained for 20 randomly selected sets of twins. The 20 pairs of measurements yield that, where X represents the twin born second. Then the Y would be the first, I would say. Find the best, as you can see, Kelly, this is definitely dependent, right? Dependent. Yeah, find the best predicted value Y hat, given that the twin born second has an IQ 103. Okay. Yeah, this question should mention clearly that Y represents the firstborn, the twin baby. The first one come out is Y, second come out is X. It should be like that. Okay. Anyway, we notice that the p-value is so low, right? It's 0. No matter what your significance level is, p-value is low. If p-value is low, no must go. Do you remember what is no? No is no linear correlation. No linear correlation. No linear pattern. No must go. That means we support there's a linear pattern, linear correlation. In fact, yeah, the R value is given. Yeah, look at the R value. R value is very close to 1, right? It's not only linear correlation exists, it has a strong positive linear correlation between the 2 variables. That makes perfect sense, right? Because they are twins, same DNA, similar DNA. Based on, so they also give you the critical values. I think it's pretty a little bit more than what we need, but we can check. All right, we can check. N is 20, alpha is 0.05. Look at here. Alpha is 0.05, alpha is 0.05, n equals 20. Oops, my bad. I didn't get all the story. There's a continue. When it's 20, probably is 0.4 something. As you can see, it's decreasing, right? Yeah, so the critical value is probably negative 0.4-ish here, positive 0.4 here. Yeah, either way, our R value fall in the critical region. Yeah, fall in the critical region, that means we're gonna deny or reject the null. Yeah, same thing would have the same result when we apply the p-value method. Yeah, either way, we would reject the null and support there is a linear correlation between the 2 variables. Why is that important? It is important because those information indicate or shows this model. What model? Your regression model, linear regression model. Your model y bar equals 5.54 plus 0.95x is a good model. Yeah, good model for what? For prediction, for doing the prediction. So since it's a good model, then we can use this model to predict. Predict what? Predict y value when x equals 103. Okay, so guys, now we are going to do some algebra. We are going to plug in x equals 103 into y bar equals 5.54 plus 0.95x. Yeah, so we're gonna do this on your calculator. 5.54 plus 0.95 103 here. All right, yeah, let's see what we have for that value on the calculator. 5.54 plus 0.95 times parentheses 103. 103.39. 39. Round 2 decimal places are needed. Yeah, it is exactly 2 decimal places. 103.39. Do you have the same thing, guys? So means when the second baby in the twin has IQ score 103, the first baby has IQ score 103.39. Interesting. Yeah, awesome, perfect. Also, you know, earlier the last question here, we have learned how to predict when the regression line is not a good model. We use y bar, right? And the first question is when all the information strongly signal the regression line is a good model, then of course we are going to use the regression line to predict. And how do we use the regression line to predict? All we need to do is plug in the value of x here to replace x. Just a little bit algebra to get a y hat, the predicted value of y. Yeah, so those two questions actually complete the prediction function of the linear regression line. Any question about the 3 questions?
I don't have a question about this, but I do have a question about the exam. When do we need to take it by? Because like most of our like stuff on Peterson needs to be completed by December 9th. Is that the date that we need to take the exam by? The final, the exam for?
Actually, I'm going to do the paperwork right after today's class. Yeah, I was going to ask you, so far I only received the formulas from Kelly. Yeah, we should appreciate we have Kelly because, you know, the reason I recruit formulas and questions is actually a strategy to engage students. But not everybody really engage. But we appreciate we have, you know, I appreciate we have a Kelly. She sent me those formulas. I hope those formulas would help you for the test. If you don't add anything later after class, when I do the paperwork for the test, I will only include those things. All right. Technically, those not really formulas. This actually kind of notes, but I will include them. For the time of the test, today is Thursday. Today is Thursday. Normally give me 1 week, right? Yeah, 7th, December 7th. From tomorrow, if you are ready, tomorrow all the way to December 7th, anytime you can drop by the testing center and take your test. And if, I don't know if they open on Friday. Also, you should check the hours by calling the testing center you are going to take the test at to check the hours. So suppose you take the test on 7th, you still have like 2 days to catch up the homework if you haven't. Does that sound good? Does that sound good? Okay, awesome. Perfect. Very good. Okay, your practice time. I want you to practice. Yeah. I have 12, 15, and 19. Yeah, let me show you one at a time. So Charlie asks, so the last day to do makeup homework is December 9th. Yes, it's in the syllabus because that's the day of all the classes close. And I need time to sort everything and submit the score to the school, right? Yeah, so I cannot extend any longer after 9th. Yeah, no problem, Charlie. Okay, let's practice number 12 first. 12, 15, 19, right? Okay, number 12. Okay, this problem would be very similar to the question 16. Yeah, this question would be very close to number 16 on the test. Take your time. Okay, I'm not gonna do it this time. You do it, and you enter this to Y1. Sorry, list 1. You enter that to L2, and you do the stat tests. You do this function. Give you 2 minutes. Give you 2 minutes. One more minute. Find your A and B. All right, time's up. what do you have for your A after rounding? Is A is around equal to 2.40? Is your B around equal to 1.3? Yeah, both of them round to 2 decimal places. Eh? 2 decimal places, then this probably 1.30, right? Awesome. Thank you, Charlene. Great. And please construct the scatter plot on your calculator and let me know which one from the 4 is the same with yours. B. Okay, awesome. Let's see. Yes, this one. Okay, more like a parabola. Yeah, this one is really linear, but we don't have that. Okay. All right. Identify a characteristic of the data that is ignored by the regression line. Yeah, the wording kind of like interesting, right? Ignored by the regression line. Yeah, which one do you choose? Is also B? Yeah. More like a parabola, left side of the parabola. Yeah, the data has a pattern that is not a straight line. Yeah. Very good. So this question would be very similar with your question number 16 on the test. All right. Yeah. Now let's go to 15. This question will be very similar with the question number 17 that you see. Suppose the question is not shuffled. Okay. I forgot to check that setting. So this question, let's work on it. Chest size, enter that at least 1. Weight, at least 2. This is about the bears again. Oh yeah. Okay. So we're gonna enter the 2 lists and then use the function to find our A and B. I probably have to do this in order to know if this is a good model or not. I'll do it with you, this one. Let me look at my scatter plot. Zoomstat. My scatter plot look like this. Okay, guys, do you have your A and B? Would you like to let me know what's your A value and the B value? One thing about the sample data is the size is pretty small. Yes, sample size is only 6. So if we have more, probably we have to catch more bears. I mean, if we have more, then maybe the linear pattern would be stronger. Okay, let's see. A is negative 172.6, B is 11.1. Kelly and Charlie have the exactly same thing. And is that the same as yours? Yay. Same, right? Yeah. How do we know if this is a good model or not? Let's go to stat tests. Go up, letter F, linear regression t-test. I'm looking at R. Yeah, calculate. Everything remains the same. Yeah, if I look at R, I would know. The R is 0.85. So around equal to 0.85. So it's kind of strong. And let me check the p-value. P-value is 0.03. Oh, okay, here. That's very important. Significance level is 0.05. Our p-value is around equal to 0.03. So p-value is low. No must go. Yeah. Reject. Reject no means we support there is a linear correlation between. There's a linear correlation between. And indicate this is a good model. Yeah, so we need to be very cautious. It really depends on this, the significance level, the criteria. Depends on the criteria. Since it's a good model, we are able to predict the Y value using the model. So we're gonna plug in x equals 51, okay? Let's see what we have. So we have a negative. Yeah, don't forget what is the negative sign. Negative sign is different from the minus sign on the calculator. Negative 172.6 plus 11.1 times 51. Close. I got 393.5 pounds. 393.5 pounds. Is the result close to the actual weight? Not. Yeah, how do we know? How do we evaluate the close or not close? This is what I do. I use the actual value to minus the predicted value. And then divided by, oh no, predicted value is 393.5. And then divided by the actual value. I'm looking for the percentage. So 452. That's a lot of difference actually. It's pretty not close. Pretty not close. Minus 393.5 and then divided by the actual value. Divided by 452. It gave me almost 13%. I think obviously not close. Okay, not close. And you might ask, now what if it's smaller? So it doesn't really give us a criteria here, right? But 13% definitely is too big. And we should choose not close. This result is not very close to the actual without bear. That means what, guys? That means this criteria, when you set the significance level 0.05 too loose, you should set that more strict. Then you don't support the linear correlation. Then you don't use the model because the model is not very good. But so this is what complicated about statistics compared with other mathematical branches. It has a very big factor from the sample, like depends on the researcher, the sample collected by the researcher. All the result, is from the sample. And sometimes the sample is not easy to get. Like this one, you have to catch those bears and measure their chest size and weigh them. I believe, only just by my estimation about the two variables, one is chest size, the other is weight, right? I believe if we have more data, the linear pattern would be a lot stronger. This is just based on my subjective estimation. I believe there's a linear correlation because the same bear, it's like a person, right? If you have a big chest, you have a big weight. Have you seen anybody have a very big chest and a very small weight? I think they are definitely have a positive correlation here. It's just the sample we have size is very small and make the prediction not very accurate. But this is probably the best they can do, right? All right, guys, so this is number 15. Is very close to number 17 on the test. The last one, we have 2 minutes, number 19. Oh, it's a small one. Okay, we can do that. I actually don't remember the order. Maybe this is but this definitely is one of the three questions. Suppose IQ score were obtained for 20. Isn't that the same thing? Twins, yeah. Very good. Same thing, right? And this indicating strong linear relationship exists. So this is a good model. So we can use the good model to predict Y just simply by plugging in IQ score of the second. Oh, this one is the firstborn. Yeah. So it depends on the programming. The programming want to have different versions of the same type of question. So sometimes they change this part, change that part. So this time you're going to plug in x equals 90. Yeah, because the p-value is so low, indicating strong. Yes, that's the same question. Yeah, only the value is different, right? Yeah, I remember earlier that's the second-born. X is second-born. In this case, X is the firstborn. And also this value is different. I remember the other one is 103. Yeah.
So the p-value is really low, but do you also look at ARM because R is so high is another test of it being good? Okay.
Exactly.
Thanks.
They should be consistent. They should give you the same result. Yeah, that's why they give you the critical value table. Yeah, I did not copy that. So for this question, you simply just plug in x equals 90 to find the result. All right, guys. Yeah, very close to one of the three questions on the review. I think I really make it clear that the review is so important. Not only the 18 questions on the review are very similar with the 18 questions on the actual test, but also if you do not pass the review, you literally cannot start the test. It will be very awkward. You go to the testing center, you spend your time in the gas, and you go there. Oops, I did not do the review. That would be really bad, right? Yeah, so please do the review. Please do the review. When you go to a Pearson, you should see a green flag in front of the review. That means that's a prerequisite condition for the test. All right, guys. So I also recommend that you complete 10.2 as well. Those 3 questions you just practiced is from 10.2. In a sense, they are closer to the 3 questions on the actual test compared with the 3 questions on the review. Again, this is the formulas or notes from Kelly. I will include them as the formula sheet and attach to the paperwork I'm going to do for your test. You should be able to take the test from tomorrow if you'd like, or you can wait for next Monday. Yeah, make sure you call them to ask the hours. All right, guys, if you have any other questions, please email me. Let me take a picture again. Take a picture. Okay, we have one more person actually join us. Yeah, that will be today. You all have a great night. Thank you for your teaching. My Tuesday and Thursday evening will be so different. Thank you, Kelly. I appreciate your participation to make the communication a lot easier. It was a great class. Yeah, actually, this is the last time we meet. Okay, guys, but you are welcome to contact me anytime. All right. If anything I can help you, just feel free to reach out. Good night.